I want to look at the polarization and bound charge in problem number 5 from the second exam from the fall 2015 semester. The z-axis is out of the page. Here is our conducting cylinder, and here is the free charge on that conducting cylinder. In the dielectric, I am showing some of the electric dipoles that form, and I'm only showing the ones that result in bound charge on the inner surface of the dielectric and those that result in charge transfer across the Gaussian surface. There will be a net negative charge inside our Gaussian surface because if an atom is just outside the Gaussian surface, the result will be negative charge pushed into the Gaussian surface, and if the atom is just inside the surface, there will be positive charge pushed out, meaning there will be an increase in the negative charge inside the Gaussian surface. So the amount of negative charge resulting because of the transfer on the outer wall of the Gaussian surface will be equal to the amount of negative bound charge that is appearing on the inner surface of the dielectric. So that bound charge is going to equal the bound surface charge on the inner wall of the dielectric here times the area of the side of that cylinder, which is 2 pi times the radius, the inner radius, which is 3 meters, times whatever length we've picked for the cylinder in the z direction. So the polarization field will look like this. We see the only place the polarization goes through the Gaussian surface is the side wall of our cylinder. So the integral of P dot ds is going to equal the magnitude of the polarization on that outer wall times the area of that outer wall, which is 2 pi rho. So that is rho there, times L. So let's make these two substitutions. So these 2 pi's cancel and the L's cancel. So the polarization is equal to minus 3 rho sub SB. This should be a B up here, over rho. And so it's only in the rho direction. So substituting for rho sub SB, we have minus 3 times minus 8 epsilon sub 0 over rho. Or finally, the polarization is equal to 24 epsilon sub 0 over rho in the rho direction.